Alright, what's going on, everybody? This video we're going to look at curves defined by parametric equations. So basically what we're going to be doing is graphing these things, and I've got a bunch of examples to do. So let's get started. So suppose that x and y are both given as a function of a third variable t called a parameter by the equations x equals f of t, y equals g of t. These are called parametric equations. Each value of t determines a point xy, which we can plot in a coordinate plane. As t varies, the point xy equals f of t, g of t varies and traces out a curve c, which we call a parametric curve. All right, so the way that we find our x and our y coordinate is based on the value of what t is. And the curve with parametric equations, x equal f of t, y equals g of t, where t is between a and b, has an initial point f of a, g of a, so we plug the a in for t, and then a terminal point f of b, g of b, so we plug the b value in for t. Now, on this, t, it doesn't necessarily represent time. As you'll notice in some of these other equations, t is not going to always be the variable. Okay. Now, in a lot of applications, t will represent the time, but it doesn't necessarily. Just because it's t doesn't mean it's going to represent time. All right, so let's go ahead and get started. So it says sketch and identify the curve defined by the parametric equations x equals t squared minus 2t and y equals t plus 1. All right, so how do we graph this thing? Well, what we want to do is let's go ahead and make a table. And what I'm going to do is I'm going to just choose some values for t. So you can pick anything you want, but what we'll do is we'll just choose -2, -1, 0, 1, 2, 3, and 4. All right. And now what I want to do is I want to take each one of these t values and plug it in where x equals t squared minus 2t and y equals t plus 1. So to get our x value, x would be -2 squared minus 2 times -2. All right, and this will give us 8. So that's 8. And then y would be -2 plus 1, which equals -1. All right, so that's what we do, and we do that with each one of these t values. And I'm not going to show the work like I did on this one, but we would take the -1, plug it in for t, get our x value, take the -1, plug it in for t, and get our y value. So let's just do that, and we can do that real quick. So we plug the -1 in for t here. That's going to give us 3. Plug the -1 in for t. That's going to give us 0. And then we plug the 0 in for t right here. That's going to be 0. Plug the 0 here. That's going to give us 1. And then we plug the 1 in. That's -1. Plug the 1 in. That's going to give us 2. And then we take the 2, plug it in for t here. That's going to give us 0. And then we plug the 2 into here. That's going to give us 3. And then we plug the 3 in. That's going to give us 3. Plug the 3 in here. That'll give us 4. And then we plug the 4 in. That'll give us 8. And 4 plus 1 is 5. All right. So now we're ready to plot these points. All right. So we got 1, 2, 3, 4, 5, 6, 7, 8. We'll just label each of these. got 1, 2, 3. We got -1, -2, -1, -2. All right, so let's plot. So the points that we're gonna plot are gonna be these points. These are our XY coordinates right here, and we just plot them. This is our x-axis, and this is our y-axis. So we're gonna plot the point 8, -1. And let's see, we'll do that in a little bit different color. So there's the point 8, -1. And this is the value where t is equal to -2. And then we're going to plot the point 3, 0. And this is the point where t is equal to -1. And then we plot the point 0, 1. All right. And this is where, let's see, this is where t is equal to 0, t equals 0. And then we plot the point -1, 2, which is about right there. This is where t is equal to 1. See what I'm talking about there? I plot this point right here, -1, 2, and that's when t is equal to 1. So I just labeled it t equals 1. And then we plot the point 0, 3, which is right here. And this is for the value t equals 2. And then we plot the point 3, 4, which is about right there. And this is when t equals 3. And then we plot the point 8, 5, which is about right in there. And this is when t is equal to 4. And then we're able to draw our graph, which is going to look something like that. All right, so that's the graph. That's the graph we drew. But we also have to label the direction. Okay, we have to label the direction also. Now, look what happens. You see when t is -2, here's our point. And then when t is -1, here's our point. So you can see we're moving in this direction here. Okay, and then when we go to t equals 0, see we're moving in, there's that point. You follow the direction that the points are going. So you label that with arrows. And that tells you the direction. All right. And so that's the graph. And then the other thing that they said, it says sketch and identify the curve defined by the parametric equations. So we can see this is a parabola. Now, let's do this. Let's look at this graph here. What is that graph? That's a parabola, isn't it? Okay. So let's verify that. Let's show that this is a parabola. And what we can do is we can take these parametric equations and eliminate the parameter. So what I'm going to do is I'm going to rewrite these parametric equations down here. So that was x equal t squared minus 2t and y equals t plus 1. So what I want to do is I want to get it in terms of x and y. So what I'm going to do is, you see over here, this equation over here is real easy to solve for t. This one over here, not so much. But this one's easy to solve for t. So if I solve this for t, I get t equals y minus 1. And what I can do is I can take this y minus 1 right here and I can plug it in for t. And so that's going to give me x equals y minus 1 squared minus 2 times y minus 1. And so what do I get? I get x equals y squared minus 2y plus 1 minus 2y plus 2. All right, so I hope everybody sees how I got this. That's from this. Remember, that is y minus 1 times y minus 1, and I just foiled it. Okay, and so that's going to give me x is equal to y squared minus 4y plus 3. And you can see here, you see that equation there? That's a parabola, y squared, and it's positive, so that opens to the right. And you can see this is there's our parabola that opens to the right. All right. All right, so let's look at this. All right, so what curve is represented by the following parametric equations? X equal cosine t, y equals sine t, where t is between 0 and 2 pi. All right, so for this one, what we want to do is we look at this and we see we've got sine and we've got cosine. What do I know about sine and cosine? Is there some kind of an identity? Okay, think about when you learned trig. Well, one of the big identities you had in trig was sine squared plus cosine squared is equal to 1. All right, so let's look at this. Well, I can deal with that. See sine I can replace with y, and cosine I can replace with x. Because isn't that what cosine is? Cosine is x, sine is y. So I'm going to rewrite this, and I'll explain to you why I'm switching them in just a second. Okay, I just wrote cosine squared plus sine squared instead of sine squared plus cosine squared, and you'll see in a minute. So let's replace cosine with x. Now, what I want you to let's just go ahead and replace it, and then I'll show you. All right. Now, remember, cosine squared t, that's the same thing as cosine t, all of that squared. And so what I did, I just replaced the cosine t with x, and the same thing for sine squared. I replaced sine with y, and that gave me y squared. And hopefully you can see why I swapped them around, why I wrote cosine squared plus sine squared, so I would have x squared plus y squared. That's why I did it. And hopefully you remember what the graph of this is. This is the graph of a circle with center at the origin, center at 0, 0, and radius 1. Remember, this is r squared, so r is 1. All right, so let's look at this graph here. All right, so we know this is a circle. Let's see how good I can draw this thing. Not too bad. The center is at 0, 0. That's where it's supposed to be. All right. So what we want to do is we want to make up a table. Okay. I've got the graph drawn, but remember we need the direction. All right. So let's do t, x, y. And for t, I'm going to choose 0 right here. And then I'm going to go up here to pi over 2. And then I'm going to go to pi. And then I'm going to go to 3 pi over 2. And then I'm going to go to 2 pi. All right. And let's go ahead, I guess right here, let's write x equal cosine t, y equal sine t. All I did, I just recopied the equations. And we know we're between 0 and 2 pi. And that's why I stopped at 2 pi here. All right, so I just wrote the equations down again so we could see them. All right, so we're going to take the 0, plug it in for t. Well, what's the cosine of 0? Yes, this is one that you should remember. That's 1. And what's the sine of 0? That's 0. All right, and then the cosine of pi over 2 is 0. The sine of pi over 2 is 1. The cosine of pi is -1. The sine of pi is 0. The cosine of 3 pi over 2 is 0. And the sine of 3 pi over 2 is -1. And then the cosine of 2 pi is 1. The sine of 2 pi is 0. So let's plot these points. So when t is 0, I've got 1, 0. This is when t equals 0. And then I got the point 0, 1, which is right here. That's when t is pi over 2. This is t equals pi over 2. So you can see that we're moving along this direction. You see that? We're going along this direction. And then I've got the point -1, 0. That's when t equals pi. And then I've got the point 0, -1. That's when t equals 3 pi over 2. And then I'm back to the point 1, 0 at t equals 2 pi. So you can actually see this point. This is my initial point. See, when I plug the 0 in, and then when I plug the 2 pi in, remember, t is between A and B. And the initial point is when you plug in A, which we got 1, 0, and the terminal point is when you plug in B, which we got 1, 0 also. So that is our initial point and our terminal point, and it's moving in this direction right here. All right. All right. So there's your graph. So the thing about these is, you may look at this and you say, oh well, I don't really know how to graph that. Well, if you eliminate the parameter, a lot of times it's easy to draw the graph because it tells you what it is. And this is just a circle, x squared plus y squared equals 1. And I'm going to do some other examples. Try to watch the whole video because these examples, you'll learn some techniques in them. So I would recommend watching it. All right, so what is this? What curve is represented by the given parametric equations? So this one's it's a little different than the previous one. In the previous example, we had sine t and cosine t. And yes, I know this was cosine and this was sine. X was cosine t, y was sine t. That's one of the difference. But the other difference is, see, here we have 2t. You see that? All right, so let's look at this. So, well, we're going to do the same relationship here. So we're going to have sine squared 2t plus cosine squared 2t equals 1, which that's actually going to give us what? X squared plus y squared equals 1. See, I replaced sine 2t with x and cosine 2t with y. All right. And so once again, do you see this? Once again, we notice we have a circle centered at the origin. Centered at the origin with radius 1. Yes, that I know it doesn't look like it's in the center, but let's pretend like I drew it in the center. A perfect circle. All right. Now, let's make a table. So I've got t, I've got x, and I've got y. I'm going to choose t to be 0, pi over 2, pi, 3 pi over 2, and 2 pi. And once again, we're going to plug them in, okay? So plug the 0 in. That's going to be the sine of 0, which is 0. Plug the 0 in here. That's going to be cosine of 0, which is 1. So you can see here, my initial point's up here now, okay? This right here is when t is equal to 0. Now let's plug in the pi over 2. So look at this. That's going to be, let me write it down. That's going to be sine of 2 times pi over 2, right? Which is, the 2's cancel. That's going to be the sine of pi, which is what? Which that is 0. And then same thing here, cosine of 2 times pi over 2. That's going to be cosine of pi, which is -1. So that point is right there. So this is when t is equal to pi over 2. All right. Now, do we have a problem here? Okay. Do we have a problem here? Because, look, when I plug in pi, what's the sine of 2 pi? That's 0. When I plug in pi here, what's the cosine of 2 pi? That's 1. So I'm going to be back up here at this point right here. So my question to you is, which way are we going? Is it going this way or is it going this way? Well, the easy thing to do here is pick a value between 0 and pi over 2. And we can see, are we going to get a point over here? We're going to get a point over here. Which way is it going? Well, if I plug pi over 4 in, 2 times pi over 4, let's just write it out. 2 times pi over 4, which that's the sine of pi over 2. And what's the sine of pi over 2? That's 1. And then the same thing if I do cosine pi over 4, that's going to be 2 times pi over 4, so that'd be cosine. Well, let me write it out so nobody will get confused. So that's going to be cosine of pi over 2. What's cosine of pi over 2? That's 0. So you can see that point's over here. Oh, look at that. We're moving in this direction. You see that? That's the direction we're moving in. All right. So as we're putting these points in, we're moving around the circle in a clockwise direction. All right. So let's go ahead and finish this up. Let's plug in the 3 pi over 2. Okay, so remember, we did pi, so this is also at pi when t equals 0 and when t equals pi. And then when we plug in 3 pi over 2, that's going to be the sine of 3 pi, which is 0. And then when we plug in 3 pi over 2, that's going to be the cosine of 3 pi. So the cosine of pi is -1. The cosine of 3 pi is also -1. When the integer in front of pi is an odd number, cosine is going to be -1. And so that's going to be right here. And so you can see this is also when that equals 3 pi over 2. And then we plug in 2 pi. So that's the sine of 4 pi, which is 0. And then the cosine of 4 pi is 1. So that's going to be up here. So this value up here, this is actually going to be t equals 0. And then what else? 0, pi, and 2 pi. So what happened here is we actually went around twice. You see that? We went around twice. All right. So I hope that problem made sense. Okay. So let's go ahead and take a look at our next problem. All right, so they want us to sketch the curve. All right, sketch the curve. X equal 3 cosine theta, y equals 4 sine theta. All right, so let's use the relationship again that cosine squared theta plus sine squared theta equals 1. Okay, notice I wrote the cosine first because that's my x. I want my x term first, my y term second. I mean, I guess it's not that big of a deal if you don't do that, but you know, it's just nice to have it like that because that's normally what we see. All right, so I need to plug in something for cosine and I need to plug in something for sine. Well, what's cosine? Well, cosine theta is what? X over 3, and sine theta is equal to y over 4. I just solved for cosine and sine, so let's plug it in. So that's going to be x over 3 squared plus y over 4 squared equals 1. So that's going to be x squared over 9 plus y squared over 16 equals 1. All right, so what is this? What in the world do we have here? Well, this is an ellipse. Okay, so we have the graph of an ellipse here. So let's draw that. So we got 1, 2, 3, 1, 2, 3, 4, 1, 2, 3, 1, 2, 3, 4. Now remember, this 9 here, that's a squared. This is b squared. This number here, this a, is equal to 3, b is equal to 4. So 3 tells us we move 3 units to the right, 3 units to the left, and this ellipse is centered at 0, 0. And then the b equals 4, that means we're going to go up 4 and down 4. And now we can sketch in this ellipse, and I know it doesn't look very good, but that's an ellipse. Okay? All right, now what do we have to do? Well, let's make a table. Okay, let's make a table. So I'm going to erase this so we can have the table right here so we can see what's going on. All right, and so I've got t, I've got x, and I've got y. And what values am I going to plug in? Well, I'm going to plug in 0, pi over 2, pi, 3 pi over 2, and 2 pi. And I'm going to plug them each into here. Well, cosine of 0 is 1. 1 times 3 is 3. Sine of 0 is 0. 0 times 4 is 0. So that's the point right here, 3, 0. Now remember, this is for t equal 0. And then I've got t equals pi over 2. Well, the cosine of pi over 2 is 0. 0 times 3 is 0. And then the sine of pi over 2 is 1. 1 times 4 is 4. Then I plug the pi in. Cosine of pi is -1. -1 times 3 is -3. Sine of pi is 0. That's 0. And then I plug the 3 pi over 2 in. That's 0 when I plug it in for cosine. Cosine of 3 pi over 2. Sine of 3 pi over 2 is -1, so that's going to make this -4. And then I plug the 2 pi in. That's cosine of 2 pi is 1. 1 times 3 is 3. And then this one's going to give me 0 when I plug it in here. So I've got the point 3, 0. Then I've got the point 0, 4. This is when t is equal to pi over 2. And then -3, 0 is here. This is when t equals pi. And then 0, -4. Well, 0, -4, that's right here. That's when t is equal to 3 pi over 2. And then 3, 0, I'm back to where t equals 2 pi. And so which direction did we go? See, as t is increasing, we're moving around this way. So this is the direction we're moving in. All right. So I hope all of this is making sense. Okay? Like I said, watch all the examples that I work. All right, look at this example. Find the parametric equation for the circle with center HK and radius 0. Oh, okay. So I wonder what the parametric equations would be. We want the equation of a circle. So I could say x is equal to, I'm going to leave a little space here, cosine t, and y equals, I'll leave a little space there, y equal sine t. I know that that's a circle, isn't it? Because didn't we do, we did this example. Well, where is it? Yeah, we did this example right here. And that was a circle, wasn't it? And this had radius 1. And one thing I noticed here, you know what? There's a 1 in front of each of these. So what if I come down here? They want a radius r. So what if I multiply the sine and cosine by r? I wonder what that would, let's just see what that would do. And so I know if I solve this for cosine, that's going to give me cosine t is x over r, and that's going to give me sine t is y over r. Let's see what happens. And so I know I have cosine squared t plus sine squared t is equal to 1, right? That's what we did in the problems before. And now I'm going to replace cosine with x over r. I'm going to replace sine with y over r. So that's going to be x over r squared plus, and then I've got y over r squared equals 1. So that's going to give me x squared over r squared plus y squared over r squared equals 1. And then if I multiply everything through by r squared, that's going to cancel them down here, and that leaves me with x squared plus y squared equals r squared. All right, so now I know that's a circle. That's a circle with radius r right there, but it does tell me it wants the center at HK. So right now I have x equal r cosine t, and I've got y equals r sine t. So what does it want us to do? It wants center at HK. Well, this center is at 0, 0. So I do want to shift h units in the x direction, and I want to shift k units in the y direction. Well, that ought to be easy. That's just x equals what? H plus r cosine t. See, this is x. I'm adding a h, and that's going to shift it one way or the other, right? And then y, I can just do what? K plus r sine t. And that's going to shift it k units in the y direction. And then I'm going to have where t is between 0 and 2 pi. And that's all they're wanting you to show right there. So that would be these would be the parametric equations. That would be your parametric equations for a circle with radius r centered at HK. All right, so let's look at this one. All right, I've got x equal sine t, y equals sine squared t. Oh, that's a little different there. So this one, it's really not so much that we have a lot of work to show on this one, as much as kind of, I guess, reasoning through it and stuff. So I wonder what this graph right here looks like. I wonder what that looks like. Well, could I write this? Y equals x squared? Think about that for a second. Yeah, because it says sine is equal to x, and if I replace sine with x, that would give me x squared. So I know it's a parabola. That's the very basic parabola, x squared. Vertex is at 0, 0, and it opens upward, right? All right, so let's draw that graph. Let's see, there's 1, 1, negative 1, negative 1. We know there's the vertex right there, right? Now, wait a minute. Before we get started, one thing that I've got to make a note of, sine t, you see the sine t here? That's between negative 1 and 1, right? Any angle you plug in for t, you're always going to get a value between negative 1 and 1 with sine, and, well, cosine as well. So if sine t is between negative 1 and 1, that would also mean that x is between negative 1 and 1 also, right? So that means, yes, it's a parabola, but it's just right here. You see that? All right. So what do we have here? Well, I mean, I guess we could maybe look at a table, I guess, but think about this. There's no restriction on t, is it? I mean, we've got sine t is between negative 1 and 1, but it doesn't tell us that t is between anything. So we can actually plug in any values we want for t. But what's going to happen here? Okay, well, we know that sine t is a periodic function, right? It's a periodic function. And the points that we're going to have, our xy points, are actually going to be sine t and sine squared t, right? That's our xy right there. And so what it's going to do, it's going to move back and forth infinitely along this parabola. Because as I'm plugging in t values, well, it's going to go up here, then it'll come back down, and, up here, back down, and all that. And that's all it's going to do, is just going to go back and forth infinitely many times. And that's what the graph would look like. Okay? I know the solution to this one may not be as satisfying as the other ones, where we actually, we went through and made the table and all that stuff. But, this is what you got here. All right? Okay, so I think, wow, this is actually, I believe, the last problem we worked. All right. All right, so let's look at this thing. It says sketch the curve with parametric equations, x equal cosine t and y equals sine 2t. Oh, okay. Well, this one's not a good one, is it? And what makes it not so good? Well, we've got cosine of t and we got sine of 2t. That 2t is messing everything up. Now, it was fine earlier when we had the 2t, because we had 2t on both of them. But notice on this one, the angles are different. Okay, so what do we actually want? Well, we need everything t. We don't want 2t, we want t. So let's see if we can get that. Well, the thing I know here is y is equal to 2 sine t cosine t. Oh, where in the world did that come from? Well, remember your double angle identities. Okay, remember that from trig. Remember sine 2t is 2 sine t cosine t. And so that actually tells me that y is equal to, let's see, what is that? 2x times sine t. Oh, what did I do there? Well, I replace cosine with x. You see that? I replace cosine with x. And so now I have sine t is equal to what? Y over 2x. And then I have cosine t is equal to x. So I can plug that into my identity. You see that? So I'm going to replace cosine with x, so that's x squared plus, and then the sine I'm going to replace with y over 2x. So that's y over 2x squared equals 1. And so that's going to give me x squared plus y squared over 4x squared equals 1. All right, so now what in the world do I do now? Well, first thing, I'm going to go ahead and multiply everything by 4x squared. Get rid of that fraction. So that's going to be 4x to the 4th plus y squared equals 4x squared. And then I'm going to move the 4x squared to the left-hand side. So 4x to the 4th plus, well, let's write the x terms together, minus 4x squared plus y squared equals 0. All right, so how about that? Now we just got to graph that thing, don't we? And guess what? We have no idea how to graph that, do we? No, we don't. But let's pull some tools out of our bag. Remember all that stuff you learned in earlier in calculus, probably in Calc 1, and also in pre-calculus. Well, look at this right here. Look at this part right here. Isn't that even? That's an even function. And that's the x part, that's even. So that means this thing is symmetrical about what? The y-axis. And then look at this thing. That's y squared. So, if you plug in 2 or negative 2, you're going to get the same thing. You see that? Or 3 or negative 3. They're both going to give you 9 after you square it. So this is telling us we are symmetrical about the x-axis. All right. All right, so let's look at this thing and see what we've got. Let's make a table. We've got t, we've got x, and we've got y. And I need to figure out some values that I'm going to plug in. And once again, let's just remind ourselves what our functions are. We've got x is equal to cosine t, y equals sine 2t. And we also know that t is between 0 and 2 pi. All right. So if we don't know how to graph this thing, what good did it do me? Okay, what good did it do me to graph that thing? Well, look at this. Let's see if we can't draw this halfway decent. Let's put that to be 1, this to be 1, this to be -1, and this to be 1. All right, so the good that did is that I know it's symmetrical about the y-axis and it's symmetrical about the x-axis. So look at this, and this is not the graph, but if I had something like this, okay, then I know, and I just have this part in the first quadrant. Well, I know it's symmetrical about the x, it's symmetrical about the y, so I know this thing could just actually flip over here, and it could flip down here, and then this could flip over here, and that would give me the graph. So what, and like I said, that's not the graph, okay? I'm just trying to explain to you about it being symmetrical. So how this benefits me to know that it's symmetrical about the x and the y axis is that's telling me that all I need to do is graph this first quadrant. That's it. And then I can mirror everything. Let me kind of see if I can't make these all about the same. I don't know. All right. So what I'm going to do here is I'm going to choose some values. But the values that I choose, I'm not going to choose like I did before. Remember, like when t was between 0 and 2 pi, I would choose 0, pi over 2, pi, and 3 pi over 2. Well, what I'm going to do now is I'm going to choose values that are just in the first quadrant. I'm going to just graph the first quadrant of it, and then I can mirror everything over because it's symmetrical. All right, so I'm going to start out choosing 0, and then what else do you think we're going to choose? We're going to choose all the way down to pi over 2 because that's 0 and this is pi over 2. Well, what else do you think I'm going to choose? Well, what do we know? Well, we know the sine and cosine of what? Pi over 6, pi over 4, pi over 3, and then I get to the pi over 2. Remember, pi over 6, that's what, 30 degrees, 45 degrees, and 60 degrees, right? All right, so let's plug them in. So if I plug 0 in, that's going to give me 1. Plug 0 in, that's going to give me 0. Sine of 0 is 0. Now let's plug in pi over 6. Well, what's the cosine of pi over 6? Well, that's what? Square root of 3 over 2. Yes, that's a 3. It doesn't look like it. 3 over 2. And then I plug the pi over 6 in here. That's what? That's sine of 2 times pi over 6, which is the sine of pi over 3. Yep. Okay, so this is what? Square root of 3 over 2. So we got square root of 3 over 2. And then we're going to plug in the pi over 4. All right, so I don't want to erase that. So if we plug in the pi over 4, cosine of pi over 4 is square root of 2 over 2. And then the sine, we plug in pi over 4. 2 times pi over 4 is, well, let's write it out. 2 times pi over 4. So that's going to be the sine of pi over 2, which that's going to be what? 1. And then we will plug in pi over 3. Well, cosine of pi over 3 is 1/2. And then we do sine. All right, so let's maybe write this down. Sine of 2 times pi over 3. That's going to be the sine of 2 pi over 3. So we've got to figure out what that is, right? All right, so to figure that out, well, you just do this. there's 2 pi over 3 right here. Do you remember reference angles? Okay, there's your reference angle. Well, that's going to be what? Pi minus 2 pi over 3, which is pi over 3. So that's pi over 3. And then the sine of pi over 3 is equal to what? Square root of 3 over 2. You see that? We are in the second quadrant, so it's still positive. Sine's positive. So this is square root of 3 over 2. And then if we plug in pi over 2, the cosine of pi over 2 is 0. And then we plug in pi over 2 here. The sine of, let's see, that's what? The sine of 2 times pi over 2, which would be the sine of 2 times pi over 2, which that would be the sine of pi, and that is 0 also. All right, so we've got our points. So let's plot them. So remember, this is 1. So now I've got the point when t is 0. That's going to be the point 1, 0. Okay, so just remember that's when t is equal to 0. And then I've got the point square root of 3 over 2, square root of 3 over 2. Well, where's square root of 3 over 2? And I'm gonna make that with a blue mark. That's gonna be about right in there and about right in there. You see that? So that's gonna be this point right here. So that's gonna be, this is gonna be for t equals pi over 6. So we can see that we're moving along this way. All right, we're moving along this way. And then I've got square root of 2, 1. Okay, well, let's see. Let's put in a half. There's a half right there. And let me move this point over a little bit. I didn't have it lined up real good, but about right there. And so square root of 2, this is 1/2. So square root of 2 over 2. Where's that going to be? Well, that's probably going to be about, let's make that with a red mark, square root of 2 over 2. That's probably going to be about right in there. And we're at the point square root of 2 over 2, 1, which is going to be about right there. And then we've got the point 1/2 square root of 3 over 2, which is going to be right here. It's going to be at the same height as that point, but right here. And then we've got the point 0, 0. All right. All right, so the way this thing's going to look is it's going to look, I guess, something like this. Okay. There it is. And remember, this is when t is equal to pi over 4. This is when t is equal to pi over 3. And this right here was when t equaled pi over 2. All right. So that's gonna help us get the direction. So see, as t is moving, as the t is increasing, we're moving along this direction here. So we're moving like this. Okay. Now, which way do we go? Well, this thing's it's going to continue moving in the pattern. So, well, where's it going to go? Well, it's going to keep going this way. You see that? It's going to keep going down this way, and it's going to come up like this. See, it's like we're taking this and we're flipping it down here. So we could actually come down here, and now let's see if I can draw that a little better. So it's going to look something like this. And then we flip this over here. It's going to look something like that. And then this can flip over. We can flip this up, and it's going to look something like that. Well, all 4 of those are supposed to look exactly the same. Okay. But that's where this comes in so handy right here, knowing the symmetry. And so how's it going to keep going? Well, is it going to go this way? Is it going to go this way? No, it's got to flow in this pattern here. Okay, it's going to keep going in the same direction. So we're moving here, here, here. You see that, how it's going around here. And there's the graph of it with its directions. So you can see that on all of the examples that we worked, the problems that we had, most all of them, just by looking, when we eliminated the parameter, we got a function that we knew how to graph, like remember x squared or the equation of a circle or something like that. And we just sketched the graph real easy, and we made our table here, and that was an easy way to see how it was moving. Well, this one, you can see what happened here is, it wasn't so good here, was it? Because of this. We don't know how to graph that. But it was helpful with the symmetry, and that made it easier for us to graph, because all we had to do was graph this one constant. This first quadrant here, and then we could just mirror everything. So I hope this video helped. Check out my other videos. Give me a like, share, and subscribe. Thanks for watching. I'll see y'all in the next one. Later.